All right, so sometimes we're going to need rational equations to solve word problems. And we're going to do some pretty basic ones here. We're not going to get too crazy. Maybe we'll see some more tougher ones later on in the year. Maybe we do our exam review. I just don't want to pound you with these because they can get complicated, but I don't think we're going to have to do any that are that crazy. They're going to all be very similar. These are going to be work problems. How long it takes to do things, mostly involving time to do things, okay? So here's an example for you. Huck Finn can paint a fence in 5 hours. After some practice, Tom Sawyer can now paint the fence in 6 hours. How long would it take Huck and Tom to paint the fence together? Now, here's the thing. We have to think about rate and each of their rates, okay, individually. Now, obviously, if Huck Finn, you got to think about this in real life. If a person could paint a fence, it takes them 5 hours to paint the whole fence. So we have a fence right here, right? Okay, so we have a fence. We have a fence. All right, a little picket. All right. By the way, I'm the worst drawer in the history of the world. All right, so we have a little fence right here. If it takes Huck Finn to paint this fence, it takes him 5 hours. So I hope it wouldn't take him 5 hours to paint that fence. But let's say it took him 5 hours, right? And Tom, if he were doing it by himself, could take him 6 hours. Do you think it would take more time or less time in order for them, if they work together, to paint the fence? So think about you and your friend, right? If you work together, do you do things quicker or does it take longer? Typically, it would go quicker, right? So while it took Huck 5 hours to paint it himself and Tom to paint it 6 hours himself, when they work together, it won't take as long, okay? So what we're going to do is we don't know how long it's going to take. We know it's going to take less than 5 hours. We don't know exactly how long it's going to take. So what we're going to do, we're going to use rational equations and kind of use this kind of logic here to help you. So Huck Finn can paint a fence in 5 hours. We're going to represent that as 1/5. Why? Because he can paint one fence in 5 hours. Got it? He can paint one fence in 5 hours. We're gonna let Tom Sawyer be represented by 1/6. Why? Because he could paint that same one fence in 6 hours. It takes him 6 hours to paint the one fence. If they work together, so if we add their rates, these are their rates, 1/5 to 1/6, right? So in other words, Huck Finn can paint 1/5 of a fence in an hour. That's another way to look at it. He could paint 1/5 of a fence in an hour. Tom Sawyer can paint 1/6 of the fence in an hour. So these are their rates and how fast they work. If they work together, so we add, how long will it take to paint the fence together? We don't know. But it's still one fence that's being painted, and we don't know how long it's going to take. So 1/x. So that's kind of how it works, all right? Very simple. So now look, we solved these, right? We've solved these in our last lesson, okay? So we know how to do this. We're going to get a common denominator. It's going to be 30x. So times, change colors, times, Christmas, times 6x, okay? Times 5x, and then times just 30. All right, so it's going to be common denominator of 30x. That's 30x. They cancel out. 6x plus, it's just solving now, right? We already know how to do this. Equals 30, and then 11x equals 30. And I know 11 doesn't go into 30. That's okay. Divide by 11. It ends up being 2.72 hours. 2.72 hours, or 2 hours. 2 hours 44 minutes. Okay, I just did 0.72 times 60. 44 minutes is 0.72 of an hour. All right, so 2 hours and 44 minutes if they work together. So teamwork, right? 5 hours alone, 6 hours alone. You work together. You basically chop that time in half, kinda. All right. So here's another one. Working together. It takes working together. So they're giving you the working together time. They're giving us the equals. it takes Sam, Jenna, and Francesco 2 hours to paint one room. So we're painting a room now, okay? So working together, it takes them 2 hours. So that's 1/2, but that's working together. That's what it's going to equal. Now there's 3, Sam, Jenna, and Francesco. So there's 3 people, so we're going to have 3 rates. When Sam works alone, he could paint one room in 6 hours, 1/6. When Jenna works alone, she could paint one room in 4 hours, one room in 4 hours. So in other words, Sam can paint 1/6 of a room in an hour, and Jenna can paint 1/4 of the room in an hour because it takes her 4 hours to paint the full room. Determine how long it would take Francesco to paint the room. So we're going to go 1/F for Francesco. All right? Francisco. I don't know why I'm saying that wrong. Okay. So we're going to go common denominator of 12, right? 2, 4, and 6. Oh, no, actually, we could do 6. We could do 6 for a common denominator. All right, so we can leave this alone. 6F, we got to do 6F. So we're going to go times F. This needs, we can't do 6. What am I doing? We do need 12. Oh, my goodness. We can't turn 4 into a, all right, so we need this to be times 2F. This is times 3F. This is times 12. And this is times 6F. All right, so we have 12F, 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 12F. There we go. And you could use X. You don't need F. All right, so 2F plus 3F. I just put F to remind me what I was doing. I'm finding Francisco's rate. All right, 6F. All right, so combine like terms. 5F plus 12 equals 6F. If you subtract 5F from both sides, you get 12 equals F. All right, so Francisco's rate, how long will it take Francisco to paint one room? 12 hours. If he worked by himself, it would take him 12 hours to paint this room. And our last one here, now, our last example is not really a word problem. It's but it's a different type of rational equation. It's a rational equation that contains more than one variable, and we're going to solve for a variable. So part A is pretty easy. It's plugging in. So you're going to use your calculator. I already did it to save time, but here's 1 over r. It's 1 over r equals 1 over x plus 1 over y. That's given. Okay. Now they're telling us x equals 2/5, so we're just going to plug that in. So we're going to get 1 over r equals 1 over 2/5 plus 1 over 3/4. Now look, that kind of looks ugly, right? So we're just going to throw this in a calculator. We're going to throw this in. Actually, we're going to throw this whole thing in our calculator. It's going to give us an answer, and then we're going to multiply by r, right? Cross multiply. So we're going to get r equals 6 over 23. This is all calculator work, all right? So you might be like, why? What is with this? Like, he didn't even do anything. Well, it's all calculator work, all right? So I'll help you in class tomorrow on how to get that in your calculator. But how about B here? Solve this equation for r. This is the most important part of this problem because this is a little tricky. So they actually had this on a Regents exam in the past, Common Core Regents exam. All right, so 1 over x plus 1 over y. All right, so now what we want to do is solve for r. Well, to solve for r, we need to get, first of all, common denominator. So what's our common denominator? Well, in the denominator, we have 3 variables, r, x, y. They can't go anywhere. They all got to stay there. So we have r. We need x, y. So we need x, y up here. We have x. We need r, y here. So we need r, y up here. And we need rx here. We need rx here. So we need rx here. So now we have a common denominator, x, r, y, x, r, y, x, r, y. All 3 denominators are the same. They cancel out. Get a common denominator, cancel out your denominators. It's exact same procedure we've been using. So now we have xy equals ry plus rx. All right, let's carry that down over here. So we have xy equals ry plus rx. we want to solve the equation for r. Well, the trouble is we have r in two separate terms, okay, but we can't combine them together. Like some people think ry plus rx is 2rxy. No, it's not. No, it's not, because they're not like terms. You can't just add those together. You can't combine those terms. So what you have to do is factor. You have to factor r, a common factor. We're going to pull out the r, and what's left? Y plus x. Look what I just did. I factored out an r. So sometimes you have to factor to solve an equation. Kind of putting everything we learned all year together, right? Putting it all together now. All right? Factoring, rational equations, multivariable, okay? Now, how do we solve for r? Well, it's r times this thing, right? So if it's multiplication, how do you undo a multiplication? Well, you divide. So we're just going to divide now by y plus x, divide by y plus x, divide both sides by y plus x, okay? And the y plus x's cancel out, because that's 1. Anything divided by itself is 1. And look what's left. R all by itself, which is what we wanted. We wanted to solve for r. So r equals this, xy over x plus y plus x, right? Over x plus y. You could leave it as y plus x. I just like to put it in alphabetical order. So xy over x plus y is what's left over, okay? And that is the equation solved for r and simplified. You can't do anything else. You can't combine the x and y at the bottom. You can't cancel anything out because you have a binomial at the bottom and a monomial at the top. So you're done. That is simplified. All right, see you in class tomorrow to practice this and those word problems. See you then.